All right, so we are going to talk about limits. Our first unit is all about limits, okay? And today we're just going to focus on what a limit is and how to find them graphically. We're going to talk about numerically, just for you to kind of get an understanding of what a limit is, but that's not particularly how we're going to find them, okay? So, first of all, go ahead and copy down the definition of the limit. Is there a reflection from the sun? Not hearing the voice? Okay, a limit is the behavior of a function as x approaches some value. Okay, so I have a couple pictures here to show you. Okay, we'll just put it all together. Okay, don't copy down the chart. Okay, but here's what's going on. Here is the function x cubed minus 1 over x minus 1. Okay, here is the graph. Let's remember that if there's any sort of factor that can cancel, we get a hole in our graph, right? So since this is a difference of cubes, we have x minus 1 over x squared plus x plus 1. Those factors are canceling out, which leaves us with a parabola with a hole, okay? Just want you to be aware of that's what's going on. We're going to talk about holes quite a bit in this chapter, or a unit, whatever you want to call it, okay? So, this is what you're going to see a lot of. The limit as x approaches 1 of f of x, you're going to be prompted with something like that, it equals 3. Let's talk about why that is numerically. As we come from both sides of 1, here I have a chart that starts at 0.75 on one side, 1.25 on the other. So if you read that chart, and as we get closer and closer and closer to 1, what is happening to those y values? They get closer and closer and closer to 3. Okay? Now, there's not an actual coordinate at 1, but as we approach 1, we are getting close and closer and closer to 3. We are approaching 3. Okay, we know this hole is at the coordinate 1, 3, and so as we get as our x values get closer to 1, our y values get closer to 3. So the limit as x approaches 1 is 3. Does that make sense? Okay, so this is what we're going to do. We're going to talk about a numeric chart one time, but that is not what method I want you to use. Okay? What I would like you to do is go ahead and write down this limit right here. The limit as x approaches 2 of x squared minus 3x plus 2 all over x minus 2. Write it down so you have it. Okay, so we're going to look at this chart, this table of numbers, just to get an idea of what is happening. So we're going to share the workload. Okay. Pod 1, I want you to plug in 1.75 to that equation. Pod 2, I want you to plug in 1.9 to the equation. Pod 3, I want you to plug in 1.99. Okay. Pod 4, I want you to plug in 1.999 and 2.001. Pod 5, 2.01. And pod 6, I want you to split up the 2.1 and 2.25. Okay? Plug those x values into the function. I'll give you a moment. Make sure you agree on the y value, please. Okay, the y value for 1.75, do we have it? 0.75? How about for 2.25? Okay, how about for 1.9? How about for 2.1? How about for 1.99?
We got 0.
How about for 2.01? Forgot who I. 1.01. Okay. 1.999.
I said 1.999.
This? You said 1 and I heard 3? In marriage counseling, like before we got married, we had to do marriage counseling. My husband and I, we went through this big thing. This is what you said. This is what I heard. Because sometimes mistakes like that happen. We use it often when we are discussing things. Okay. 1.999.
0.999.
And let me guess. Did you get 1.001 for the other one? Okay, so we kind of see a pattern here. What values are the y's approaching as our x's get close to 2? 1. Okay, so we could say, you wrote this down, the limit as x approaches 2 of x squared. Okay, so we can say that the limit equals 1. I apologize for the delay in my board. I don't know. Needs the wireless, right? Yeah. Okay. Now, this is not an efficient or effective way for looking at limits. Okay, it's not always going to be accurate. Okay, and it's a waste of your time. But I want you to see numerically what is happening. Now, what I would expect would be for you to what I would expect you to be able to do is consider the graph. Okay, so let's talk about the graph of this equation right here. Okay, when you talked about rational functions last year, your teacher made a big point to make sure that you factored and simplified before you made your graph. Do you remember that? Okay. A lot of you had me, so you better be shaking here. Okay, so what does that numerator factor to? X what? And x minus 1. So what happens is those factors cancel out. Okay? And we're left with the linear equation x minus 1. But what feature does our graph have? It has a hole where? At x equals 2. So the line x minus 1, we have a y-intercept of -1 and then a slope of 1. But when we get to x is 2, we have a hole. So if we look at this problem graphically, we can see that as, like, I kind of like to think of it as like if you put like two little cars on the graph, as you drive your cars closer and closer and closer to the x value, then what is the y value that you're approaching? So if we approach this from both sides, okay, as we get closer and closer to 1, our y value gets closer and closer to 2. That hole is at 1, 2. So the limit as x approaches 1, excuse me, I'm saying that backwards. The hole is at 2, 1. So the limit as we approach 2 is 1. Okay? It's okay that there's not a coordinate there. It's just the value we are approaching. It's like when you and your siblings play that game, like Don't Touch Me, and then you get like this close, like we're trying to say I'm not touching you. Okay, that's kind of what a limit is. Okay, getting as close as you can without actually touching it. Raise your hand if you did that. What? Fair enough. All right, let's look at this graph. Okay, maybe sketch this graph very quickly. Don't worry about the equation, just sketch the graph. Basically the line with the hole and then the coordinate down below. I want to know what the limit is as x approaches 2 of this function. As we approach x is 2, what y value are we approaching? Zero? Any other answers? 1. 1 or 0. We need to decide which is which. Okay? Let's remember that when we talk about limits, we want to be on the function and we want to stay on the function. So as we are approaching x is 2 on the function, we're getting close to this hole, which has a y value of 1. So the limit is actually going to be 1, even though our function value at 2 would be 0. Okay, so there's a difference that we need to talk about, right? Our function value is 0, but the limit as we approach 2 is 1 because that's where that hole is. I'm glad you brought that up so we can talk about it. Okay. All right. Now, the limit is not always going to exist. There are 3 times that the limit does not exist, okay? So what I need you to do, we're going to write down the 3 times that a limit does not exist, okay? Is this too old of a picture for you? You don't?
Oh my gosh, that was your problem.
The limit does not exist. It's from Mean Girls. I think I'm going to have to get rid of it. I think it's too old now. Okay. So there are 3 ways a limit does not exist. Before you get to writing, I want you to write these 3, but leave room for a graph that I'm going to show you. So write 1, skip a few lines for a graph. Write 2, skip a few lines for a graph. So I'm going to show you examples of all of these. I'm going to show you 3 pictures of what these 3 look like. Okay. Your pictures don't have to be fabulous, but they need to at least give you the idea of what's going on. Now, the picture for number 1 approaches a different number from the right and the left. So the right and left hand sides aren't matching up. The picture I'm going to show you for this first one is actually a graph that you need to be familiar with. Okay, so you should probably also write the equation with it. Okay. Okay. So here is, oh, I need to. There we go. So here is our graph. Basically, from 0 to infinity, we're at 1, and from 0 to negative infinity, we're at negative 1. So as we approach 0, we're approaching from 2 different ways. Those don't match up. The limit does not exist. And we write it as D N E. So I would write this so you know the equation, and I would write, or I would just sketch a quick drawing of that graph. This is a graph that is going to pop up more than once. Okay, so I need you to remember it. Okay, let's talk about it is why it's the graph that it is. Okay, x divided by x is always going to be 1, right? But when we put the absolute value in the numerator, that's forcing the numerator to always be positive. So here we're dividing x by x, right? But here, when we put negative numbers in, the numerator's positive, but the denominator stays negative, right? And so we're getting negative 1 instead, okay? And as we approach 0, we're doing so from 2 different ways, right? If we drive the car from the left, we drive the car from the right, they're approaching 2 different values. The limit does not exist, okay? D and E is all you have to write, okay? The second way a limit fails to exist is when it is, what is the word used? Increases or decreases without bounds. What do you think that's going to look like? Okay, good. It's just going to keep rising or keep falling. So here's an example of an asymptote. Okay? So this is the graph 1 over x squared, and as we approach 0, that function continues to get higher and higher and higher, and we know there's an asymptote. It's just going to keep going towards infinity, so we say that it does not exist. Okay? Later, we will describe some of these as infinity or negative infinity, okay, but it's not actually a value, so it does not exist. Jackson described like an exponential function. Okay, that keeps going up, 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 up. That would be increasing without bounds. Okay. For right now, you're going to see a lot of asymptote examples until we get to infinite limits. Okay. And then the third way, this is probably one of my favorite graphs. If there is oscillating behavior, right?
If somebody turned that in for their roller coaster questions.
Right? Well, they would not have fun as they approach 0 because the limit does not exist. Okay? We can't even tell what's going on right there, right? It's just a big mess of oscillating behavior. Limit doesn't exist. What I'm really excited is to come around and see all of your drawings for this one. Scribble. Okay, so we're going to go through 2 examples and then we're going to do an activity. Okay? So I'm going to put a graph up here. As a group, I'm going to give you about a minute to come up with the 4 answers, and then I'm going to ask you to give me some answers. All right? Here's your graph, nice and big for you. I want to know those 4 items. I'll give you 1 minute to discuss. I should probably hear some talking. Well, like the whole thing, it's the coordinate right? So like up there, if I said what's the whatever the coordinate is.
So I would say the limit doesn't exist.
I think it's okay. Okay. So as x approaches 3, okay, it's okay that there's not a hole. Which one doesn't exist?
You don't have to approach it.
Like,
You can approach it.
1.5.
So just as you it's getting closer.
It's okay if it's not like super exact.
All right.
Yeah. Nope. If there's a coordinate, just put that white coordinate. Okay, the limit as x approaches 3. Part 1, what do you have for us?
I just kind of eyeballed it and said 1.75.
Okay, 1.75, 1.5. It's tough to tell on this graph, especially since it's like not in your hands, right? But as we approach 3, we're talking about like this coordinate right here. As we approach 3, our y value is approaching 1.5 or 1.75. I'd accept either answer, okay, because you're kind of estimating, right? It's okay that there's not a hole, just give me that y coordinate, all right? The limit as x approaches 1, pod 2. And it does not exist because the right and the left are approaching 2 different values. Okay? Does not exist. F of 1, pod 3. And we know that because there is a, okay, there's a coordinate there. That filled in coordinate, that is the function value. Okay, so the limit doesn't exist, but the function value exists. That's okay. That's okay. The limit as x approaches 4, pod 4. The limit as x approaches 4 is 2 because that's the y coordinate of that hole. Perfect. Okay, let's try one more to really, well, this is a little bit different, I guess. I want to know where the limit doesn't exist. List all the x values where the limit doesn't exist. With your pod.
Two works because of the
Okay, we're gonna come together. Pod 5, give me one. X equals 4 and yx equals 4. They're going towards infinity. Very good. Pod 6. -2. Why? Okay, so there, you could give two different reasons for this one, right? You could say the unbounded behavior, or you could say they're approaching two different numbers, right? Pod 1, any others?
2.
2, why?
Because they're approaching the value.
What are we approaching from the right side?
On the right side, you're approaching the 0, I guess.
You're approaching what?
You're approaching, you're going different directions.
Okay, so I agree that they might be going different directions this way, but as we come from the left and the right from both sides of 2, we're actually approaching the same pole, aren't we? Okay, so 2 actually does exist. The limit as x approaches 2 would be 1/2 because they're both approaching the pole. Okay? That was a good conversation to have though. Pod 2, is there another one? 0. Why? We're approaching two different ways. Okay, it kind of looks like a jump, right? Here we're here, and we have to jump up here. Okay. We're approaching two different values. The limit doesn't exist. Okay, and that should take care of it. Okay, those are the three places. Okay, I have given you a gold piece of paper. At the beginning of each unit, you will get a gold sheet. If you had me last year, this is familiar for you. This is your homework for the entire unit. Do not lose that sheet of paper. Okay? You see bolded problems on there. I didn't get you guys some. Sorry about that. You see bolded problems and you see non-bolded problems. I understand that you are busy people and sometimes you're crammed for time. If that is the case, you have to at least do the bolded problems for me. The non-bolded problems are ones that if you feel you don't have time to do, I'm not going to be super upset about, but I feel that to be successful, you should do all the problems that I put on that piece of paper. Okay? So your homework is listed there. You don't need to write it down, but what I do need to do is